I think most of you know what Dim Sum Labs is about, but have you been to Dim Sum Labs before? No? So what brought you here? Just curious? Do you know what a hack space is? Not really? So the way I always described it in the past, years ago when I was actually here living, was that back home in Australia, I have a garage full of tools. Most of my friends have got garages full of tools. When I come and move to Hong Kong, I don't have anywhere to do my projects. I don't have a space that I can have tools in. And I certainly don't have a group of friends who can get together and buy tools that I couldn't otherwise afford, like a laser cutter and multiple different 3D printers and various woodworking and turning equipment and test equipment and surface mount soldering. All the things that you can have to work on your projects and the space to work on it is what Dim Sum Labs is. But most of all, it's a group of people. It's a community that you can get together with, get help on your projects, show off your projects, give talks if you want. Your talks can be recorded and we can put them online for you too. And yeah, so Dim Sum Labs is it's the space you have in order to have a workshop and a place to do things that has the tools, that is open all the time, that you can go to get away from home and have the time and the space to get things done. So Dim Sum Labs is a volunteer organisation and is supported entirely by your membership. So if you like us, please talk to somebody who will tell you how to become a member or read one of our many things on the walls, and they can tell you all about all the other things that can happen if you're a member. I was once involved in Dim Sum Labs, but that was almost 5 years ago now. When I left Hong Kong, I obviously stopped being a member. But tonight, hey Jerry, did you know we've got a talk on tonight? Mm-hmm. Did you know we've got a talk on tonight? Nope. We're just starting our talk, just so you know. So tonight, I'm going to give a presentation on n3n, which is the VPN project that I've been working on for 8 years, I think. And recently, the project itself has changed. So in this talk, I want to show you what the project is, why it's changed, and how the change can completely change the way the project works, how you can use it, and a little bit about how it works. So I'll start with, what is n3n? And it's a VPN. First and foremost, its point for existence, its reason for using it, is to get a VPN. It's not like every other VPN because it actually does NAT piercing and provides what I like to call a distributed Ethernet switch. It's implemented in user space. It doesn't actually require a kernel module, and this has both pros and cons, and is intentionally intended to be small and relatively simple to get ported to other things or to install on something that it already works on. I'll go through all of these things and tell you what they actually mean, because I'm using technology terms there, and I don't want to confuse you. I just want to use the right terms to begin with. So when I say it's a peer-to-peer VPN, I mean that most VPNs will actually talk to a central point to send their packets. And if the traffic that they're talking needs to talk to another person still on the VPN, it goes to the central node and then back out to the other person. So there's no direct connection. And historically speaking, this is what most VPNs wanted, because you've got a VPN to talk to, say, your workplace, and the VPN central point is sitting right next to the servers from your workplace. So it doesn't have a problem with the fact that you're going in and then maybe back out again. But if you have traffic amongst a number of peers, you might want to send that traffic directly amongst the peers, rather than going to a central node and back out again. So n3n attempts to do that. It does not always succeed, due to the next point that I'll come to. But when it does succeed, the traffic goes directly between the two peers. So for instance, one of the ways I use it is for backups. I send backups between two servers, and I don't have to have all of that traffic go to a central node and then back out again to the second server. Other people might use it for other things like gaming or video conferencing, all of which do peer-to-peer traffic. They're not peer-to-server. And the way it achieves this peer-to-peer communication in a modern computing environment basically requires you to pierce the NAT. Most people's network connections go through some kind of address translation, network address translation. And that network address translation makes it difficult for you to have a peer-to-peer connection. So in order for you to work around that, you need to pierce. So there's a bunch of different techniques and some protocols for working around this, and they don't always work because there are a lot of different NAT firewalls and a lot of different NAT technologies in use, and the combination of these will make it difficult sometimes. So there's always a fallback to go via a central node. So even though it's a peer-to-peer VPN, it still can end up going through the central node. And there are obviously improvements that could be made. In the time since the NAT piercing code was written, people have improved the way that the techniques available for doing the NAT piercing. So that's one of the things I hope to do in the future, is improve some of this. And I called it a distributed Ethernet switch. Like the Ethernet switch that you might have seen powering the Ethernet sockets for all of the plugs in Dim Sum Labs, or the Ethernet switch that's part of your home Wi-Fi network, n3n provides a virtual Ethernet switch. The way that the packets are forwarded through each other is different to the way that a lot of other VPNs do it. It forwards Ethernet packets. And it does this to make some things simpler. It's not as perfect for doing the direct peer-to-server connections that other VPNs will do, but it's a more flexible way. For instance, if you are doing peer-to-peer communication, you might be doing something that's not just as simple as TCP/IP peer-to-peer. You might be doing other protocols, and that'll work because this is doing Ethernet packets. So when you've got a number of computers attached into an n3n network, they all form collectively a distributed Ethernet switch. And that's what it looks like to the operating system. It looks like you've just plugged a cable into a switch. It's a virtual cable, it's a virtual switch. And there are a lot of VPNs that are built with high-speed networking acceleration and kernel support for that. This makes things faster, but it makes things more tied to the specific kernel you're using. You might have to have a specific Windows device driver installed to make your VPN work. That limits the ability for you to use the VPN in a more wider sense. So n3n at the moment is entirely based on using user space networking. It doesn't have any kernel drivers, it doesn't require any kernel drivers, which is a trade-off because it doesn't have the speed acceleration that you could get from doing this. I think it's a reasonable trade-off, and it's also an area that in the future somebody interested could add in support for some kind of kernel acceleration. But my focus is on making it work widely on lots of areas. Because it doesn't require a kernel driver, it doesn't require signed drivers, it doesn't require special drivers to be customized for each and every environment. It should be easy to port to most operating systems because the TUNTAP interface that it does use has been around for 20 years, and most common operating systems have an equivalent of it. Which is one of the reasons why I focus on low deployment requirements as well. I'm trying to make it simpler to install places. There is obviously a lot of very well-packaged commercial software that does VPNs. They're obviously designed to be easy to install. This is a community project. This is a simple VPN written by 5 to 8 different people. It's not as seamlessly packaged. So stating it as one of the core goals is important. When features are suggested or improvements are added, each time I have to say, okay, is this going to make it more or less complex to install, more or less required resources, RAM and disk space, because I want to focus on making it low deployment requirements. making it easier for people to use, making it easier for people to hack on, making it small enough that one person can understand the source code and be able to edit, change, modify, improve the process. Not so complex that it can do fast, high-speed kernel accelerated networking. It's not the point. I didn't write n3n. I said, you know, I think there's 5 to 8 different people who have worked on it. It actually came from another project, an earlier project, n2n. n2n was written by the same people behind the ntop project. They needed to solve a problem that needed peer-to-peer networking, so they wrote this software back in 2008. I think I've been using it since about 2012, 2014. Can't remember when I first started using it, and then I started contributing some patches to it in about 2015. And over time, it's had a number of different project teams, a number of different feature sets, but it's been around for a while, and it's been in various different operating systems. So it was originally n2n, but back last year, around about October, the ntop parent project made a licensing change to it, which was a bit of a surprise to the 3 of us who were doing volunteer-based support and volunteer-based development on it. We're a bit surprised to have this change happen. So obviously they had some kind of change that they wanted to make. They didn't really communicate, but the end result was that I needed to fork it into a new project in order to not violate their requirements for licensing, but still be able to contribute my improvements. The only way to do that was to take the version that was last released with the old licensing requirements and create a new project based on that version. So, forking the project. At that point, I basically became the maintainer of a new project. I gave it a new name, it's got a new organization, it's got a new structure of control and authorized people. It's got some of the same people who were working on the old project in it, but it's a new project. Suddenly I became the maintainer of the project, which means that the history went on from where I showed you before. And earlier on this year, around about Easter, I was able to make the first public release of my n3n project, which just happened to be version 3.3. So I had 3 3s in a row, which was great. For alliteration, I get all the 3s. And I had a number of discussions, discussions about this licensing change, which is why it's probably worth describing to you how that came about. What is going on here? What they changed, it was a GPL3 licensed project, so that's a fairly standard license. And I had been contributing to the project for many years under that license, so all my contributions were contributed under that same license. Same with everybody else who was contributing outside of the parent organization. Sure, they had their own internal contribution requirements for any employees that were doing contributions. But what they changed is they added a CLA, a contributor license agreement. And what that is effectively a legally binding document that they want you to sign before you can contribute. So it's an agreement that I'm signing that allows me to be a contributor. It normally includes some words in that document where I grant licensing agreement to the people who are using my contributions. And what they're probably trying to achieve with this is to get a guarantee from me, the contributor, that the contributions I'm making are not encumbered by patents or prior art, or I'm not just copying and pasting in them from somebody else's work. So by me signing this document, I am saying that I agree that I am contributing code that is able to be used by this project. Now this is the positive side of it. This is what it's supposed to be for. Unfortunately, contributor license agreements historically have had issues. They're a legal document. This brings in a certain amount of bureaucracy. You've got to have people tracking who has signed it and who hasn't, whether they are actually abiding by the requirements that they are signing, whether or not the people are allowed to anonymously create contributions changes, because as an anonymous entity, you can't sign a legal document and be bound by it. So the project may not accept your CLA if you try and sign it anonymously. I mean, is that signing? You haven't signed it, you haven't signed your name to it. At least one of the contributors to this project had that problem. And it tends towards an asymmetry of power. You've got the company that is, well, the organisation, it may not be a company, that has asked for the CLA. They've generally got a lawyer involved to write their CLA. So they've got somebody very skilled in the arts of writing legal documents to prepare the document that they are then asking some random guy on the internet who just wants to commit a spelling mistake fix to sign. So there's an asymmetry of understanding of the legal system there. But from my point of view, one of the biggest concerns is that final point I've got on the slide. Because I am giving them, as part of the signing the CLA, I'm giving them certain rights to license my software. Generally what happens in the documents that I've seen other people use for CLAs is that you're giving them the right to relicense it as well. So I'm giving them the right to use my contributions and giving them the right to let other people use my contributions. So they could turn around and say, well, yes, I know that you've contributed this under GPL3, but we are going to make a profit out of it. And while it'll be available for GPL3 for anybody who finds it that way, we're going to sell it for profit to our customers. Or we're going to change it to be a license that I don't like for other reasons. And I've got no control over that because the CLA says that I have given them the rights to make onwards licensing, that they can relicense it to other people. So some other projects have discovered it to their displeasure that the organisation in charge of the CLA documents then turned around and said, right, well, we're just going to do it our own way and take over and do things differently. So there are other reasons. Obviously, I've tried to line out 3 or 4 of them there, but that was the key one for me, is that I was doing contributions for the public good, and I wanted to be ironclad in my guarantee that there is no point in the future that they could take my contributions and twist them in such a way that they were no longer publicly available for all. There are alternatives. You don't have to use a CLA. One common thing that people have done these days, modern projects have very strong history. They have a version control system, often Git, and in that version control system they can track who wrote every single line. Historically speaking, when people started coming up with ideas about how licensing worked and how open source worked and how a CLA might be written, that wasn't always the case. So in a modern project, we have the ability to track much clearly who owns and who wrote and where it came from for each line of the code, down to a date and a time, a person, and hopefully a comment saying, hey, I copied this out of this other project. Or, if they didn't say that, some confidence that they didn't copy it from another project, that they wrote it themselves. So without having to change anything at all, if we write good and clear commit messages when we commit code into our repository, we often are making it easier to enforce copyright later. Well, not enforce, to maintain the same copyright. Some other projects, a good example is the Linux kernel, have chosen to do a thing called a developer certificate of origin, which instead of being a legally binding document that you sign once in order to be accepted to contribute to the project, each and every time you make any contribution to the project, you are saying, this contribution, I certify the origin of this contribution. And they have their own specific process for doing that, and it's not a legal process, it's just by contributing, you agree that. So it doesn't have the same lawyers involved, doesn't have the same signing problems involved. And it means that they can case by case accept variations to this should there be a reason to it. And the final option is maybe having a CLA, but engaging the community during that CLA process. Because I found that they didn't really engage us. I'd say there's only like 2 or 3 of us who are actually doing the maintenance of the old project. And we were all surprised by this change. We didn't expect it. We didn't know it was coming. When it did happen, we immediately, I wrote a letter to the guy in charge of the organisation saying, hey, what's going on here? Is there something that's changed? Can you explain what's going on? And unfortunately, I got a less than complete reply. He didn't really engage with my request. He didn't explain the details of what was going on. He certainly didn't give me any confidence that the reason for the CLA was benign. I was hoping to be convinced. I was hoping that I might have had some rationale that I wasn't aware of and didn't know that he would talk me through, and that we could have had a discussion amongst all of the volunteers of what CLA involved and why and how we were doing it and the complexities of the various situations. None of that discussion happened. And basically what I wanted was, if you've got a community project and you're making a change to that project, you've got to remember that the community around the project comes from the projects being a community, and communities have to change together. They have to discuss and they have to be brought along if it's going to be a massive change that they're surprised by. So after all of that, I moved on. I forked the project. And a lot of times when I describe what I'm working on, people say, well, why not just use this other VPN? There's lots of them out there. So one in particular that a lot of people have seen is modern, is used in some places fairly widely, is the WireGuard VPN. And so I can compare what I'm building with n3n to WireGuard. WireGuard is intended to be in the kernel. Is intended to be layer 3, so it doesn't build a distributed Ethernet switch, it builds an IP network. Is intended to be client to server. Now WireGuard can be built in such a way that it's not quite client to server, but the basic expectation is client to server. And the difficulty in setting it up is slightly larger. You've got, to set up WireGuard, you've got to do a cryptographic setup. This makes it more secure. It's certainly more designed to be a secure environment. But it makes it harder to set up from scratch because you have to have a process for creating your cryptographic keys, distributing those keys amongst people, and they are all different keys. So the goals of n3n don't quite match that. I don't want to compete with WireGuard, right? So it's a completely different setup. Another VPN project that I have used in the past, and I've seen a lot of people talk about, is OpenVPN. OpenVPN is very, very comprehensively flexible. It can do almost all of the same things that n3n can do, which leads to the one difference, the one clear difference, is that it's way too configurable. Setting up OpenVPN is a process of reading thousands of different options and coordinating them all to work, which means you might end up having a suboptimal setup. It's also a slightly older system. It's built a while ago, so it's not quite thinking the same way as a more modern system might be. And because it's old and heavily used by people, it's a lot harder for it to change. So I'm trying to build this shareable node config is the way I've phrased it up there, but I'm trying to build a simplified way of configuring things. And I'm trying to build a way that I can access other computers behind firewalls, behind home gateways, in various data centers. I'm not trying to build something that's completely 100% secure. So on top of my VPN, I'll still run SSH to connect to the other servers on my VPN. I'll still run SSL to talk to the various web services that I might be running on my VPN. It's much more about getting a community of things plugged together so I can talk amongst themselves than it is about trying to be the perfect security. And because I want to have all these things talk to each other, I like being able to support easily these multiple different environments and setups, which gives me the ability to say, okay, I can onboard almost anything onto my network. And because I'm using it as a peer-to-peer network, as a backup between different peers on my network, that's one of the reasons I prefer it, is because I'm trying to send bulk chunks of data between 4 or 5 different physical locations. And there's only one central point, like in many other simple VPN setups. That would mean that I would be involving a triangle of traffic for everything, rather than just going across. It'd have to go up and down. So, I tried to summarize the 3 reasons I liked it, but I also have other reasons. I like that it's small and simple and I can hack on it. I like that I've got history with it. I like that I've been able to work on it for a long time. So, it's my baby. I like it. But I tried to summarize it down to, here are 3 technical reasons why I prefer it, that may or may not be reasons you could use it. But it's certainly a different type of technology for you to look at than what you might be seeing for other VPNs. So as a project, I tried to make sure I defined some core goals for it. Obviously, there's the simple one, right? There's one core goal. I forked the project, I created the project to avoid the CLA. But I have some, more constructive goals. I want to stay compatible with n3n. I know there are a whole lot of people using n3n for various home network setups and home friendship group setups. So I don't want to have to tell them, hey, my thing's better, but you all have to switch. So if I main protocol compatible with the old n2n, then one person can switch and say, yeah, that worked. And then 3 people can switch, and then 10 people can switch. At no point is there this massive flag day where everybody has to switch over all at once. And I want to continue that. If they make changes to the n2n project, I'm going to be looking at their changes and cherry picking what changes they make to maintain protocol compatibility. And their license does allow that because they are publishing their work with GPL3. I can take things from their work and use it without having to sign their CLA because it's just published. I've also defined 3 different interfaces that are publicly visible. There's the config file, which most people will interact with. I don't want to break, from my first public release, I don't want to break the config file. So there's the one config file can work going forwards in the future as well. I don't want to make any more changes to the way the command line works. So if you're running it to debug it or test it from the command line, the options that are involved there, I'm trying to make them backwards compatibility from my first public release. And there's a management interface, a HTTP management interface, that under the hood it uses a remote procedure call, so JSON RPC. And so that's a series of procedure calls that I want to keep the same. So again, if somebody else builds on top of this project and uses the management API to help enhance their system, I'm not going to break their experience by changing it significantly. And those 3 things were the 3 big things I changed in doing my public release. I fixed a bunch of bugs, I changed some documentation, but the features that I added when I forked to n3n were basically setting these things in stone, making the changes so I'd be happy that they didn't have to change further in the future. But I've talked in abstract about how it works and what it's like. I'm going to go through a couple of the actual concepts used in the VPN. First, we've got supernodes. This is my equivalent of that central server that the VPN talks to. It provides a central coordination point, just like a normal regular VPN. It needs a public IP address in order to do that. And it, as the central introduction point, allows you to do some simple amounts of access control. It's not the same level as the access control that you get over a centralized VPN, but it has some elements of that, so it can be used in that way. And if the NAT piercing fails, the supernodes are used for forwarding the packets that can't be forwarded peer-to-peer. Each node on the network is an edge node. So they are the peers, and when I describe the peer-to-peer. And these are the actual software that provides the VPN. So you might end up with, in some networks, you might end up with one server, one computer, running both a supernode and an edge node. And then obviously that server is on the network, could be on the network. But you can also not run both of them. The clients will all run the edge nodes software. The central introduction point will just run the supernode software. And when you join the network, you're joining a community. So you have a community name. This is supposed to be public. You join my community. We're going to get together and do some LAN gaming. Join my community. So those nodes with the same community are what forms this virtual Ethernet network. And there is a shared key to join that as well. So you've got a public name for the community and a private key that only the people who are joining the network know. The supernode only gets to see the public name. If the traffic is encrypted with a key, the supernode doesn't actually see what's in the traffic. So you can run a public supernode and not have anybody actually snooping on the traffic. And in order to make things simple for people to actually use the system, there is some element of IP address assignment in there. So when your edge node joins the network, it can be issued with an IP address, and then you can automatically communicate with other people on the network using a similar IP address in multiple different ways. And because it's a virtual Ethernet network, you can actually just have a node on the network that's running a DHCP server and have arbitrarily complicated settings. But there are simple ones as well. So the way they can talk to each other is what I want to describe. Now that is actually big enough to see, good. On my screen, the writing's a lot smaller. Obviously, you've got the edge and the supernode I've described, and they will say hello to each other. The edge will say hello to the public supernode. More edges will join the same supernode. And as the second edge joins, it will tend to discover the first edge and set up the peer-to-peer connection to it. More edges obviously can join, and they will all keep on connecting, and so on and so on. This means there's a limit to the total number of edges you can have before you end up with too much traffic in your virtual Ethernet segment. But that's the same as having a physical Ethernet segment. There's a limit to how many people you can plug into one collection of Ethernet switches before you've got too many people. So yeah, you're not going to have thousands of people plugged into the one community. But it's intended for small communities. For redundancy and reliability, you can add extra supernodes, and the supernodes talk to each other, and some of the edges will reconnect to a different supernode. They may choose it based on different criteria. They may be forced to choose a specific supernode, or it could be one of the more obvious latency or the one with the best name. There's a couple of different systems for choosing which supernode they talk to. And this doesn't stop the peer-to-peer network from happening. And the supernodes themselves all exchange information about who's connected to them. So again, if there are any packets that need forwarding not peer-to-peer, the supernode cluster will communicate that information so that it maintains this information, which allows one of the supernodes to disappear or there to be a fragmented network somewhere and still get some capacity for the network to continue. So hopefully I've told you enough information that you're really excited. This is where you all cheer, right? Yeah? Hey! I'm not actually surprised that you're not that excited, but still, you might be asking, how do I get started? So this is one of the areas I've tried to make relatively straightforward. There are releases made on the GitHub infrastructure. There's or automatic configuration for GitHub to build and release new versions of the n3n software. So you can always go to the latest release, and there will be a number of different things there. There's packages for a couple of different Unix operating systems, and there's exe files for Windows. And there's a couple other things as well. There's exe files for other operating systems, for Unix as well. Not all of the possible things that could be built are there on the release page, and that's more because I didn't want to overwhelm it at the beginning. So I've got a couple of different architectures. I've got downloadable files that work on a Raspberry Pi, as well as downloadable files that will work on an Intel system. I've even got 32-bit executables if you're running it on Windows XP, because some of the communities of people who are using this software are doing retro gaming. So they might have old games that were before people used TCP/IP or network gaming, and LAN gaming used to be a thing. You'd take your computer into a big warehouse and you play with people who are in the same room. Using that as retro software, that worked fine. But if you're not in the same room, you can no longer do that unless you have a distributed Ethernet VPN. So because there were some people who were asking for how they could run their LAN games on XP, I've actually made some improvements to the software. So I've ported it to Windows XP, ported it to last century. Once you've downloaded it, you need to install it. If you're downloading a package, there are packages for Debian, Ubuntu, Red Hat, and the Red Hat packages will probably work on a number of other Red Hat similar systems. If you're using those packages, they come with the scripts. You install the package, they work. If you're compiling it from source code, it is a make install system. You can simply use things that have worked for 30 or 40 years to install it. If you've got a Windows exe file, it's a case of just dropping the exe file into some directory that you want to store it in, because it doesn't need a specific installer to do it. To configure it, it needs a config file. If you're configuring the super node, it's a completely different process, and sometimes it doesn't need a config file. To configure the edge nodes, it needs one config file named after the network name you want to give this. And you can see there on the screen, I've got the simplest config is 4 lines long. You put the config file in the right spot, and it'll know to automatically load it. And there are extensive options which are all documented. The command line interface will actually tell you how to understand the options if you ask it. You can say help config and it'll show you. Once you've configured it, you need to run it. If you've installed it from a package, you'll generally be running on a modern system and you'll be using a thing called systemd, and then it becomes as simple as saying start at my network, where my network is the same name as the config file we used in the previous slide. And that finds the config file, starts the config file, and starts the network up. On Windows, same idea. You say start my network. There are plenty of people who are using different operating systems, and the process is not supposed to be complicated. It can just be started using a standard way that other daemons have been started for years. Once it's running, there is a management interface that you can actually check to see if it's working okay. That interface is by default only enabled on Windows because it's exposing a port that may actually interrupt other things. On a Linux or Unix-like system, it uses a non-TCP port. So I've disabled it by default, but it can be enabled. So if you've got the management interface enabled, you can just go straight to the URL and it brings up a web page and shows you that it's connected or not and what it's connected to and how many other nodes it's found in its peer-to-peer connection. To get the same information out of a system where it's been installed, there is a command line tool that talks to the same API and will request the same information. And that command line tool can do other things as well. It's just a Python script, so it could be made to work on Windows, but that would be a much more complicated install process, which is another half of why I said, okay, the simplest answer is to enable the HTTP port on Windows and then tell people, once you've installed it, you can just click on this link and they'll get a page showing them the information rather than have to install Python first. As I said before, I'd made some changes compared to n3n. So I made changes to all those 3 areas that I wanted to stabilize. The config file used to be very difficult to understand, very poorly documented. So I changed it to be very similar to a Windows INI file, which is a simple and easy to edit file. And I made sure that to write full text help for all these options. Those are a fairly big amount of work right there. And the important thing for me is that the future can expose this helps text to more people. At the moment, you might get an error message, but in the future I could say, did you mean to read the document? Here is a paragraph describing exactly what's going on. The command line interface for starting and configuring it in the past was had more than 26 different options, and most people who were running it were typing all of those options in. They were writing little batch scripts that would type them all in for them, and it was just, what does that function do? What does this option do? What are these things? It was very hard to keep track of. So the new command line interface I have reduced to as minimal as possible to make it simpler for people to use. Defaulting to saying that if you want to set an option, you can set it in the config file. And also adding to the environment so that there's the ability to ask the system to try and help you a little bit more. And I've touched on the management API a bit already, but previously there wasn't a management API that you could use easily through standards. So JSON RPC is a relatively common standard, and obviously the built-in web server means that I can give this HTML page to people. But it also allows me to expose a bunch of monitoring information. So monitoring and statistics were not massively exposed in the old system. I'm trying to make sure that's a very clear thing that I do. So I've got information when I add a feature, I've got the statistics needed to see, is the feature working? Is it working well? Can I feed that back to somebody by looking at these metrics? And I did a whole lot of other cleanups as well. And I'm still doing cleanups. I've found, I think, 4 major bugs that would have made some of the mesh difficult to establish, that had been there for 5 or 6 years, and because I spent all the effort to fork the project, I finally found the time to figure out why some of my communities were not meshing the way I expected. So there's a bunch of little things like that are just things that I found while I was working on it. And all in all, the current state is that I've got some users, I've got people using it, I've got at least 2 contributors still contributing as well as just me. I have a co-maintainer, so it's not just me being the maintainer, it's one of the other contributors from the old n3n project. And I'm trying to grow the awareness amongst the community as I work out just how much effort I want to put into marketing. I mean, People have said I need a website. I certainly need a logo, because without a logo I can't print stickers off and give stickers to everyone. But I still have quite a lot of future plans for what I want to do on it, on top of just marketing and sales and awareness. I mean, I say sales, I'm not trying to sell this is not a corporate thing. But I want to sell people on the idea. And in order to convince people to use it, some of these things, some of these future plans are important. Like at the moment, the VPN can run IPv6 inside the VPN, but it can't use IPv6 outside the VPN. So it can't send VPN traffic to people who have public addresses that are IPv6 public addresses. It's technically simple to do, but to do it right, I have to go back and clean up a bunch of things in the code base. And cleaning up that code base is also gives me the opportunity to optimize the speed of the encryption and compression routines that are used. There's a whole lot of options in there that are hard to, that are there. There are optimizations that are already in the code base, but are very hard to actually expose to people in an easy way. So I need to want to go in and clean that up. The packages that I've built for this project haven't been submitted upstream to the actual distributions. So I want to get to the point where the packages are good enough that I can actually have them included in the operating systems. Fingers crossed, 2 weeks ago I had a hacking session with a friend of mine in Europe, and fingers crossed it will be included in the n3n project codebase as a fully integrated package. Not perfectly configurable with the n3n config language, but it's a starting point where it makes it easy to install. I want to have better tests. One of the things that wasn't present for a long time in the past was knowing whether or not you've broken the protocol. So given that I've got this very clear goal that I want to have compatibility with the old protocol, I want to keep adding test frameworks to this project so that I can prove for each commit, have I broken compatibility with something? And I've also made this guarantee that I'm not going to have backwards incompatible changes to those various APIs. So I should have more tests to do that. And I mentioned the metrics before and the statistics and monitoring. I want to add features based on evidence. So one of the features that people have asked for quite a lot is UPnP support. I have no evidence. We added it. We created the feature. We added the feature. But I have no evidence about whether it's working or not. There's no statistics for this feature. So why did we choose to add it? How do we know that it was the right feature to add? I don't know. So I want to, in the future, fix that. And I've got some long-term goals as well. Much less likely to be things I can easily, immediately do, or much less possible that I could give hints to other people on how to do them. But they're all things that would make the project more useful in the long term. Question?
Quick interruption. Midjourney just created a logo for you.
I'm not going to use an AI logo, but thanks for the suggestion. So one of the most important things on the long-term plan is better NAT piercing. I know what we can do to improve it, but it requires a bunch of infrastructure framework to be done first. Some of the framework that I'm doing for the IPv6 work will assist with doing the NAT piercing work. So the stuff on the horizon gives me a goal to try and guide my current work to make it more easy to do in the future. And that's pretty much all I have to tell you about n3n right now. But if you've got any questions, I'd love to hear them.
Thank you so much first. How are you finding the discoverability of the project right now? As in,
I'm tracking it mostly through GitHub stars. Because it's only on GitHub, so that's the only thing to really track. I'm getting a slow but steady growth since I first published it. So I don't think it's discoverable. I am trying to rely on word of mouth. doing things like this and getting published on YouTube is obviously going to help. Like I said, I've got some ideas of how I could make it more discoverable, but I'm not going to, I don't know, I'm not going to have a big bang, I'm not going to have a big splash, I'm not going to have adverts, it's not going to be much more discoverable. So I just have to get it in use. This is part of getting into project repositories. If it's in somebody's distribution, they might stumble upon it.
So do you need the run here for your project?
Do I need the what, sorry?
Do you need someone to help you?
Yeah. I'm looking for anybody who's interested in helping.
Is your project?
Yep.
Okay. Yeah. So what do you need? Someone of what skill?
Well, all of the things on the near future plans are all things that could use help. There's a couple of tickets in the GitHub trouble ticket system that say project plans for the future and have as a label need help. So, you know.
That sounds good because it's a new type of VPN project. Right?
Yeah.
So can you show me the link?
Yes. There you go.
So why virtual network? Why not just use the normal internet?
Because I can't do IPX networking
Yeah.
over the internet.
Okay. Right, layer 2.
Fair.
But I mean that's the smart ass answer. Why a virtual network? It provides me with access. It provides me with a small amount of encryption. It provides me with the ability to coordinate with a small set of people if I wanted to do LAN gaming, or, you know, like I've described, my use case is more about shuffling backups around from the various cloud servers I've got.
Right.
So-
That's how we do over the normal internet.
Oh, sure. But by doing this, I have one access method that works whether I'm in a hotel room, at my home, at a friend's place, or in a hack space. You know, it means that I can pick up my cloud server, which are intended to be easily destroyed and recreated. I can pick up my cloud server and move it to a different cloud and not have to worry about the network infrastructure that might be different about the different cloud.
Right. Yeah.
So it's not going to give me the speed, it's not going to give me the flexibility of just doing it over the internet, but I get different flexibilities from it instead.
Well, makes sense. I should play with this.
I quite like this idea of like supporting retro games, because that's
Yeah, it's
I like the layer 2 bits.
yeah.
And the layer 2 bits have suggested a bunch of crazy ideas too. Like I could put LLDP into the VPN and have various things discover themselves automatically because it's pretending to be an Ethernet switch.
Yeah.
But none of that's been implemented because at the moment it's trying to be a simple Ethernet switch.
It's a lot of broadcast.
Yeah,
Ethernet, right? So
yeah. There's a limit to how much you can have because of the broadcast.
if you have a big network, then it's going to be slow.
So because a lot of people had that problem,
Yeah.
there are flags
Yeah.
to filter both broadcast and or multicast. So by default, it allows this traffic because that way everything works perfectly.
Right.
But if you find yourself in a large enough network or a network with the right kind of traffic
Right.
that it causes problems, you can just flip these flags and turn it off.
Okay. Wonder how that works.
What do you mean how it works? I can tell you how it works.
Right.
You mean how do you maintain?
Ethernet is all, it's
Yeah.
wired.
Okay. So if you turn off the multicast packets, then you're turning off the ability to run IPv6 inside the VPN. So that's how that works. And there's a bunch of other protocols that have the same kind of thing. If you turn off broadcast,
Yeah.
then what you're doing is you're turning off. You're not turning off all broadcasts because the ARP requests
Yeah.
still go through and still
Yes,
work.
Yeah.
But the network, the edge software will now look at the broadcasts that it's sending and try and determine whether they are on or off net,
Where
and
you
it
should
will
go.
filter them. Well, yeah, well, no, it won't route them. It'll filter them. It'll say, this broadcast traffic looks like it's trying to talk to something that is not on this little local community. I'm just not going to send it. So it attempts to filter the amount of traffic.
I see.
Yeah.
Just don't.
So it's less about broadcasting and more about routing. If it looks like the packet's trying to do something that it's unexpected,
Yeah.
you turn on this flag
Yeah.
and it limits the amount of those packets that get into the network. And yeah, obviously there are some limits because you'll get too much traffic. So I would discourage you from using it, but there is even a filtering system built into the edge, so you can write IP rules. I would discourage you using it because every system that this currently works on has a firewall system. So you can just use your normal operating system firewall to filter the traffic to make the, if you know there's traffic that shouldn't be in the virtual community, you can filter it at your firewall.
Okay.
In terms of kind of port scanning things, can you run those kinds of shenanigans?
Yeah,
Yeah.
they're just IP traffic.
So from that point of view, you should still treat it as an internet computer.
Yep.
Or,
Yep.
Yeah.
Absolutely. Every person who joins the community is protected by, at minimum, the community name, which is public, and the pre-shared key, which is only one copy and paste away from being public.
Yes.
So it is a semi-private network. There are things you can turn on. There are these additional features for username and a couple of additional parts you can turn on for it that I haven't used much because they don't fit my use model, but they are intended to try and focus on that, so you can discover that one person has done something bad and revoke their single access. But even in that case, the peer-to-peer nature means that you can't fully control. Once you're on the network, you might have a peer relationship with somebody even though you've been kicked off from a management level.
Do you, I guess you can run your own supernode, you don't have to
Yep.
use a public supernode.
There is at the
Wow.
moment only one public supernode that I'm aware of, and that's the one from the original project that I forked from. So I'm currently trying to think about whether I can get some nodes for n3n running, and then I can say these are the n3n supernodes, and then that is mostly useful for writing documents for examples. Here is an example that just works because here is a supernode that is already working.
Yeah.
But I think a lot of people run their own supernode because it's intended to be simple to run the supernode.
Okay. And do you have visibility on, does the supernode report to the network how many peers it has connected and things like that?
It doesn't so much report to the network as the management API exposes that information.
Okay.
So if you're a normal user on the network, you can't ask the supernode for much. Obviously, the thing you can ask the supernode for is, hey, I want to talk to this MAC address and find a public address for that. So you're probably getting a lot of the information that is supposedly private anyway. But the running management interface for the supernode is not a public interface. So you'd probably have somebody who actually ran the supernode be in a privileged position to ask that API, tell me the list of connected peers, what are their public addresses, etc.
Okay. Yeah. And do you have any sort of control other than you said you can have usernames and stuff like that, but do
Yep.
you have like IP or it was just filtering
Not at the
IP
moment.
supernode like firewall to kind of reject anything that's outside of an IP range or things like that?
Yeah, not at the moment. Obviously, if you configure the firewall on the host running the supernode, you can do what you're saying. But I can suggest that to you. Use your operating system provider firewall. But in terms of adding a feature to the supernode, it feels like it's moving beyond the scope of a simple, easy to install system
Yeah.
and moving into a more security conscious system. It's like, well, why don't you use this other VPN which does that better? So try and stay focused.
Yeah, no.
Yeah.
That's a good goal.
And it's a goal that reduces the amount of work I have to do too. So I'm also trying to make sure that my role as maintainer doesn't become larger by just expanding the scope of the project.
Yeah.
And was it not exactly secure, and for what things would you then not use it?
Well, I mean, it's only partially secure because of the nature of its simplicity. I think you came in after I'd said some of these things, but what it has is the community that you join is secured by this pre-shared key. That's the primary way of doing it. So if somebody cuts and pastes that pre-shared key, then anybody could join that community. The three things I've got this is the config file. The three things you need to join the network are the name of the supernode to use, and possibly its port, the name of the community you wish to join on that supernode, and the key. And of them, 2 of them are public. So it's semi-private as a network. It's not, don't treat it as being perfectly secure.
Well, you have to find a way to exchange that secret.
Yeah, so there's an out-of-bound method where, you hand your friend a bit of paper with the secret on it, or email them because you don't mind the fact that email's not encrypted. Obviously, you choose your level of security there. This is where monitoring on the supermode can identify that there are surprisingly large number of people joining. Maybe we need to change the key. It's it's not intended to have a big upfront amount of security. It's intended to be simple to join. So I would use it in the cases where I also have control over other things. Like, I will run it as my access network and then use SSH on top of it. So SSH gives me the true security, whereas n3n just gives me a basic amount of encryption. I will run my backups over it, but a lot of my backups are also running over SSH. Some of my backups are running with a different protocol that's got an SSL on it. So again, if somebody's getting into the network, it doesn't damage it.
So is the communication is the sending of the packets, does it have an encryption over it?
Yeah, it's optional. If you don't specify a key, it will actually function, and that's a question for the future of whether or not that becomes discouraged.
Yeah.
The same way that many years ago you used to be able to tell SSH, I want an SSH connection, but turn off encryption. And then over time, people realized that was a bad idea. As SSH got used for everything, the people who could use SSH stopped being the same people who could make the trade-off about whether they should use encryption or not. So at the moment, it has that trade-off easily available. You can just not specify a key, and it obviously cannot encrypt the packets.
So there's not a password in the traditional sense. It is kind of a partial encryption.
Yeah, it's an encryption key. Yeah.
Encryption key. Okay. Yeah.
And then when you add on the username and password on top of that, that is a password in the usual sense.
Yeah.
And you've got a question of how you distribute the user database amongst your cluster of supernodes. So it adds on a little bit of feature, it adds on a little bit of management complexity.
Okay. Well, thank you so much for the presentation.
Homework.
Any questions that you think of afterwards? I'm easily discoverable on the internet.
Do the edge nodes need a public static IP?
No, the edge nodes don't. The supernode does, because it is the public point that people connect to introduce themselves. If an edge node has a public IP, then it's a lot easier for it to do the peer-to-peer communication because there's generally no NAT involved. But 2 edge nodes without public IPs can talk to each other seamlessly. And if the NAT piercing works, they'll talk to each other peer-to-peer. So the whole thing is based on, you've got to be able to have all of the edges work without a public IP.
So maybe David interesting about it. Yeah.
Cool. Well, thank you very much for listening.
Very interesting about your thought here.
And I'll be around for a little bit longer. Or if you want to find me online, shoot me an email, create a PR or a bug a ticket in the GitHub. Maybe come down and have a chat to me. Thanks.
Thank you.